Alright, everyone, so this is Alex Kennedy back again. Again, we are just here today just to talk a little bit more about IV bolus in this next video. So for this one, we're just going to go over a sample problem of how we would set up an IV bolus equation using given values and what we know. So again, this is putting it all together. So say we are told we have a drug with a dose of 50 milligrams, a tau of 8 hours, a volume of distribution of 30 liters, a t-hat, and a t-half of 5 hours. So one thing we need for the calculation is our K. So again, if we remember, K is 0.693 divided by our t-half, which is the same thing as 0.693 over 5 hours, which gives us a K of 0.139 hours per negative 1. So again, using our initial equation of C2 is equal to C1 times e to the negative KT. That becomes CPT is equal to CP naught times e to the negative KT. That becomes CPT is equal to dose over VD times e to the negative KT. Which again, if we plug in our values, CPT equals 50 milligrams dose over 30 liters volume distribution times e to negative 0.139 hours per 1 times t. So with this equation, given any time t, we can solve for a concentration at that time t. So say we want to find the third dose. So this is where we want to get our multiple dosing factor involved. So again, we would take our initial equation, CPT is equal to 50 milligrams over 30 liters times e to the negative 0.139 hours negative 1 times t. Then we multiply by our multiple dosing factor, which again is the 1 minus e to the negative nk tau, all over 1 minus e to the negative k tau. So if we do that, we get 1 minus e negative 3 for our n times our k times our tau all over 1 minus e to negative 0.139 our negative 1 times our tau. And then say we want to do steady state, this is where we use our steady state factor. So again, same initial equation times our steady state factor of 1 all over 1 minus e to negative k tau. So if we do that, again, as we see, that would become 1 over 1 minus e to the negative 0.139 times 8 hours. So again, this is how, with given information, we can come up with an equation to calculate the initial concentration of a drug in the first dose at any time t, the calculation of the concentration at any time t at the third dose or any other dose if we would change the n, and the concentration at any time t at steady state. So again, this is just a little example to put it all together to give a better picture of how we can use information for IV bolus to come up with our equation. So again, I hope this was all very helpful for you.